Okay, so how do we value the option then? We've set out the futures price tree and we want to obtain the value of a call option. Call, if it were European, the 6-month European option, we want that value, and we also want the value of the American call. So with the futures prices set out in blue, then we want to, once those futures prices are established, we actually don't know this value here. And we don't know this value here, and this is what we actually want to find out. We don't know that. That's something that we've got to determine. To estimate it, we've got to initially have all the futures prices we have. They're in blue. Then we've got to get the terminal option prices. To get the terminal option price, basically we can say that the value of the call at expiration is equal to the maximum of the futures price minus the relative exercise, so the futures minus K or 0. So whichever is maximum. In other words, we never get a negative value. If we subtract 80.99 from the strike price of 30, because the strike price of 60. So if we subtract 60, keep in mind the strike price here of the option, the strike price is 60. If we subtract 60 from 80.99.15, we would get 20.99.15. Okay, so I've done the same here. Okay, it's the maximum of what the F, so C maximum of F minus the exercise of 60 or 0, and that's equal to 20.99. And because the other two values are either equal to 60 or less than 60, the maximum of 60 minus 60 is 0, and the maximum of 44 minus 60, the strike, or 0, well, that would be a negative value, but because we say maximum of these two, then because this is a 0, if we have a negative value here, then we default to the 0. Okay, so that's the terminal option prices, Then we need to find out the value at B, the value at C, and the value at A. To estimate the value at C and the value at A, we might follow in line here. So we have worked out, we need to estimate, again, going back to our futures, go back to our formula for a moment. The formula that we use for backward recursion is F. In fact, I might take these two just to plug in, copy, go back into our futures, into our worksheet. Okay, and we can put these in here just to note. Okay, and pause. Okay, so we have both of these formula here now, which are from the Cox-Ross-Rubinstein tree, but for option futures, and we have worked out P. But to go from the terminal value of the options, to go back here, I must use this backward recursion formula, where I have P by FU by 1 minus P FD E negative RT. Now the formula, the numerical values I have here. So for value for node B, right, for node B here, I want to determine what that value is. To estimate that, I take P and multiply it by this value. So P, which is this 46, P gets multiplied by 20.99.15, and 1 minus P by 0, and then that produces this value here. Okay, so to see how I obtained that value, again, it's equal to this cell here is E negative R, E negative R by T. The T is the time step. The time step, we have it over here. T is the time step here, A4. And then I want to multiply that by P by the 20, 99. So we have 20, 99, 15 gets multiplied by P, gets multiplied by P, plus 1 minus P, 1 minus P multiplied by 0. Okay, 0, 0. And that produces 95178. 95178. Now in the case below, we have 0 and 0. So when I say E negative R by the time step P times FU plus 1 minus P FD, because FU and FD from the perspective of C are both 0, that in turn produces a 0 which goes here, and that's what I have here. And then the final estimation in terms of the European option, and I'm working out the value of the European option here because we don't have any other decision rules imposed for the moment. When I take the same formula, F by P times FU plus 1 minus PFD E negative RT, okay, E negative RT, P is the 046 by FU, FU is the 951, the 95178 times 1 minus P, 1 minus P FD, which is 0, that produces a value then of 431, 546, okay, and that's the value of the European option. And then just to verify that, I have some Cox-Ross-Rubinstein code, code, where the underlying is a futures price. And so in this instance here, the values that I have are the same as the values set out in the question. Okay, so if you like, I'm going to verify the result here that I have using an actual Cox-Ross-Rubinstein tree nested in VBA. And I'm going to use a two-step tree where the volatility is 30%, the risk-free rate is equal to 8%, both the strike, the futures in the strike is 60 and 60, time period 6 months, risk-free rate 8%. Let's take a look at the code here for this function. Right, let's take a look at this function in VBA. So I go into the developer, and for the American Cox-Ross-Rubinstein, right, it's same as before. This is code that basically follows in line with code developed by Fabrice Roux. I make one small change. It's code that's used to set out Cox-Ross-Rubinstein. It's I follow in line with Fabrice Roux, but I make one change. Instead of E to the power of R negative Q, here I follow P is equal to 1 minus D divided by U minus D. Okay, again, P is equal to 1 minus D over U minus D. Otherwise, it's a Cox-Ross-Rubinstein tree where both the American option and the European option is set out. And I'll set a link to a file where you can pull down this code in a hyperlink below the video. Okay, so let's have a look then at this two-step tree. If I put 2 steps in, the value I obtain from this tree is 431, 546, 431, 546. So this code seems to be working, and in fact I've already verified this code. There was a paper by Chaudhry, Journal of Futures Markets, 1995. So Chaudhry, and the paper is a 1995 paper from the Journal of Derivatives, and he set out some estimations for a futures contract using binomial model, and the model was the binomial model was based on Cox-Ross-Rubinstein. Now if we can find it, it's at the end here. Okay, the numbers we have here with binomial model. In fact, I'll bring it over. I took a snippet out of the paper, and I'll pause here. Okay, so using Chaudhry, 1995, from the Journal of Futures Markets. He had some values here worked out for American futures put option values using Binomial. Okay, so this is the Binomial, and the number of steps in his tree was equivalent to, if we can take a look at it for a moment, 750 steps. So in the small detail relating back to the futures, we had 750 steps, and I had parameter values. Let's pause for a second. Okay, so what we have here is parameter values, F and K are both 100, T is equal to 0.25, R was equal to 8%, so the risk-free rate was 8%, volatility 20. What's the value using a binomial? And again, this is for the American option. And I took that same function again, Cox-Ross-Rubinstein tree for futures. And we have futures price for 80, 90, 100, 110, 120. So the futures price being 80, 90, 100, 110, 120. And the values I obtained using a data table. Okay, so I used the data table here to run this. And in using the data table, I obtained 20, 1058, 1058.60, 392, 094, 014 as estimates. And again, we go back into the VBA function for running that. This was the VBA function. So this code, we can see, works for where the step size is 750. I'm replicating the results in this Journal of Futures Markets paper 1995 by Chaudhry, and also in estimating when I come back in and I look at the this example here in a two-step binomial model, but for European options where E denotes European, right? The value I get for two-step tree is the same as the value I got from manually working out the European case. Okay, now the next step here was get the American option. The American option follows the same lines. I mean, I have it beneath, but maybe I'll go here. And in this instance, I'm following in line with what I had before, same set of figures as before. So I take this parameter set out in the question. Instead of saying that the option is European, I say it's American, and it's a two-step tree. Again, I'm using CRR3F, that VBA code. The value obtained here is 440, so that's the value I should obtain for the American option. Let's just see how we would estimate the American option. And okay, so let's, using the parameters that I have here, same question. How does the American tree change? Actually, not much difference. Same basic steps. Future prices have to be determined as before. The terminal option prices have to be obtained, same as before. But for the American option, there's an extra in the two-step tree. There's a decision I've got to make. Do I use the retime value, or do I take the intrinsic value of the option? Okay, so in the European option, I purely applied this function here. But for the American option, one more extra decision has to be made. Do I take the intrinsic value or the time value of the option? Do I take the intrinsic value, which is bigger? And if I exercise immediately in the two-step tree, instead of just using the time value, I would have got, if I take 60, subtracted 60 away from the 69.71, I would have got 971, which is higher than the 951.78, which I had before. And instead of using this in the final step, I say, instead of having a 95178 multiplied by P